Okay, so this is the next part, or the next video on chapter 5.6. Now we're going to be talking about mean and standard deviation of probability distributions. Okay, so mean and standard deviation of probability distributions. The mean, this mean we write with the lowercase Greek letter mu. We also use this before for population mean, but when we see mu here, we're talking about mean of a probability distribution. And it's also called the expected value. We're going to get into more serious word problems about expected value in the next video. And the definition we have here is it's the long-range average outcome of a repeated experiment. Now, the formula for finding mean of a probability distribution is to multiply each possible outcome by its probability and then add up all of those products. A way that, the formula that your book gives is this, where they use the summation symbol, which means take everything like this and add them all together. The x's here represent the possible outcomes of the experiment. And then this, like p with x next to it in parentheses, which we would read this p of x, is the probability that's associated with each possible outcome. Now the formula for standard deviation, which this will need to see an example. It's unfortunately, I don't have an easy way you can do this on your calculators. But anyway, our formula for standard deviation is there's two options you can use. Both of these will give you the same answer, is to take the first, figure out what the mean is, square it. Then you want to take each possible outcome, square it, multiply it by its associated probability, and then add all of those up. Then subtract the mean squared, then take the square root. Or the other way you could calculate the standard deviation is to first take each possible outcome, subtract the mean from it, square that number, then multiply it by its associated probability, and then add all of them up. Okay, so now let's look at this example. Here we're being asked to find the mean and standard deviation of the given probability distribution. So this probability distribution has already been given to us. This is actually the probability distribution for the number of heads that could come up when we flip 3 coins. You can compare this to the sample space you should have in your notes from some earlier sections, or it may have been a homework problem. But right now we'll just assume this is given to us without any context, and we want to figure out the mean and standard deviation. In order to find our mean, what we need to do is multiply each possible outcome by its associated probability and then add all of them up. So I'm just going to extend this table out so we can write all of our information in here. Okay, so we're going to calculate each x times p of x, or each outcome times its probability. So we have 0 times 1 over 8, which is 0, 1 times 3 over 8, which is 3 over 8, 2 times 3 over 8, 6 over 8, and 3 times 1 over 8, which gives us 3 over 8. And now the mean is equal to the sum of all of these. Right, so if we add 0 plus 3 over 8 plus 6 over 8 plus 3 over 8, that's going to give us our mean. So we get 12 over 8 here, or mu is equal to 1.5. Okay. Now for standard deviation, let's go back to that formula we had. And by the way, you don't need to memorize these formulas now, because the only way that we can possibly test you is open book. So, but you still do need to study. I'll talk more about exams later on Google Classroom. Okay. Right, so we have our formulas here. So what we're going to need to do in each way of finding it first, we'll calculate it this way, or using this formula, and then we'll calculate the standard deviation using this formula. So if we're calculating it using this formula, we need to square each x value and multiply it by p of x. We've already found our mean, so we can square it. So this one is a little bit less work. This one is going to get us the same answer, but there's a little bit more work involved. Okay, so we'll make now a column for x squared, where we're going to be taking each x value over here, we're going to be squaring it, and then we're going to multiply them by their associated probability, right? So we have 0 squared is 0, 1 squared is 1, 2 squared is 4, and 3 squared is 9. Now we can take each value here and multiply it by its associated probability. So now we're going to be finding the x squared times p of x part of this formula. So we take each x squared and then we multiply it by its associated probability over here. So okay, and now that we've done that, we can add up all of these to find this big piece of this part that's in parentheses over here, the sum of x squared times p of x. So this is equal to the sum of all of these. So 0 plus 3 over 8 plus 12 over 8 plus 9 over 8. And that is going to give us 24 over 8, which is equal to 3. So now we're going to set this number 3 aside. Or actually, we can plug everything into this formula right now because we have pretty much all of the information that we need. Now, sigma, or standard deviation, is equal to, right, we have this value here, that's 1.5, minus the, oh no, that was our mean, that was the wrong thing. Okay, so sigma, right, x squared p of x is 3, minus mean squared, which is 1.5 squared. And this ends up being radical 0.75, which works out to be 0.8660. Okay, so this is one way to calculate the standard deviation. Now we'll go through the other formula that you could choose to use. And that's what we're going to be doing with the rest of this space over here. So we want to take each x value, subtract the mean, and then we want to square that value and then multiply it by the associated probability. Okay, so first we'll do x minus the mean. So what do we have here? 0 minus, actually we'll just do the whole thing squared at once to save some space. Right, so 0 minus the mean, which is 1.5. Right, so this is 0 minus 1.5 squared, 1 minus 1.5 squared, and so on. Yes, so that's also 2.25. Okay, now that we have that, let's see what's next in the formula. We now have to multiply everything, or all of these answers, by p of x, and then we want to add all of them up together. Okay. So what do we have here? X minus mean squared, oh no, not mean squared, squared on the outside, times p of x. Okay. So that's just taking each one of these and multiplying it by the associated probability. Okay, so we multiply all of these out, and then, you know, I'm expressing them as fractions, but you could also express these as decimals, as long as they're not repeating decimals and they actually do terminate somewhere, that's okay. You know, if they terminate like this, it's fine. If they're repeating, you know, try to express them as fractions. Anyway, so now we're going to add all of these up, because that's what this part of the formula tells us to do, right? This is saying take the sum of everything we found over here. So now we're looking for the sum of, that's if we add all of these guys up, we end up with 24 over 32. And now we're going to use the other standard deviation formula to find our standard deviation. Right, so now we're just taking the square root of one number, 24 over 32, and that happens to equal 0.75, 24 over 32. So again, we get the standard deviation is the same 0.8660. So now if you have one of these calculators, I just want to quickly show you that, you can actually do all of this in one step, inside your calculator at once. So let's say we wanted to do x minus mu squared and then multiply that by p of x for, let's do the last row where we're not, working with easy zeros and ones. This is the way that you could input, right? We have first the x minus mu part, right? So if our x, right, for 3 minus our mean was 1.5 in parentheses squared like that times 1 over 8, which was the associated probability, we'd hit enter, we get 0.28125. Right, now if we want to change this to a fraction, we would hit the math button over here, and then the first thing that comes up is frac, and we hit enter, then hit enter again, and now it changes it to a fraction. So it's pretty easy to go between decimals and fractions. You can go, back and forth. So this way, you don't have to round off and lose information. You can just express your answers as fractions. Let's look at another example now. Here we're going to be given a probability distribution. First, they're asking us to do something different here, which is to find the missing p of x value. Then they're asking us to construct a probability histogram, and then they're asking us to find the mean and standard deviation. In order to do part A, we have to make use of this fact. To make use of the fact that the sum of the probabilities in any probability distribution is always equal to 1. So what that means is all of these p of x values should add up to 1. We're going to use that fact and some algebra in order to figure out what our missing value should be. We'll start over here for part A. I'm just writing here. We know that the sum of all of the probabilities is equal to 1. That's how we would read this. Right? The sum of all the p of x values or the sum of all the probabilities is 1. So 1 is equal to 0.3 plus 0.5 plus w. So 1 is equal to 0.8 plus w. We subtract 0.8 from both sides. And we get 0.2 is equal to w. Okay. Now that we've done that, we can move on to the next part of our problem, which is to construct a probability histogram. What we'll be doing is, now that we know what this missing p of x value is, we have all of our possible outcomes and we have their probabilities. So the probabilities will go on the y-axis and all of the possible outcomes will go on the x-axis. Probabilities on the y-axis, possible outcomes or x values on the x-axis. And we're going to have to be a little bit careful with this. So the x values we have that come up are 2, 4, and 5. Right, so we're not going to have any bars at 1 and we're not going to have any bars at 3 because they never show up in our probability distribution. We're just going to be putting bars on values that actually show up in our probability distribution. So 2 has a probability of 0.3, so we're going to give 2 a bar of that height. And then 3 doesn't show up here, so we don't give it a bar. 4 has a probability of 0.5, so we're going to give it a bar of that height. And then 5 has a probability of 0.2, so we're going to give it a bar of that height. Okay, and then this should have some title. I'm just going to call it probability histogram because we don't have any story behind it, so we can't really name it anything relevant to the situation because we don't know anything about this. We just know the possible outcomes and what their probabilities are. Now in part C, we want to find the mean and standard deviation. So because we've seen an example like this before, if you want to pause the video here and try and work it out yourself, you can do that, and then I'll go over the solution with you. We'll take a look at the solution to this one. So we're again going to need to use the formulas we have for mean and standard deviation, right? So first, to find our mean, what we can do here is multiply each value or each possible outcome by its associated probability and then add all of them up. Right, so 2 times 0.3, 4 times 0.5, and 5 times 0.2. And we end up with, let's see, 0.6, 2, and 1. And the sum of these ends up being 3.6. Okay, so that's our mean. We have that answer. So now we want to find the standard deviation. So let's just extend this. I'll be finding the standard deviation using this formula, but you're also free to try and work it out using this formula. They'll both give you the same answer. Okay, so we need to find our x squared times p of x. And because I have a calculator that's capable of doing this, we'll just write it as it would appear. So this is going to be 2 squared times 0.3, 4 squared times 0.5, 5 squared times 0.2. And we end up with 1.2, 8, 5. And the sum of all of these is 14.2. Now that we have this information, we can plug it into our standard deviation formula. Okay, so over here we have 14.2, and our mean is 3.6. So 14.2 minus 3.6 squared. If you put this in your calculator as like this, it'll give you the direct solution, but we can simplify this a little bit. We end up with 14.2 minus 12.96, which works out to be the square root of 1.24, which works out to be 1.1136.